Okay, so on the previous section we were using SohCahToa, but you might have noticed that we were only finding missing sides from our right angle triangles. But what if we wanted to find the missing angle instead? Well, it's actually going to work in a very, very similar way, and it might actually be slightly easier because there's not much rearranging to do here. So let's have a look at the first question. So I've got my right angle triangle. Yes, I'm given two sides, but I'm not trying to find a third, so it's definitely not Pythagoras because it has nothing to do with angles. So it's going to be SohCahToa again. So let's start in exactly the same way. So label the sides. And then identify which equation we're using. So we're not given O and we're not finding it, so let's cross that out. So it's A and H, so that's the K part. So in other words, cos of the angle, which we're told is X. And that equals the adjacent, which is 5, over the hypotenuse of 8.5. So now all that we need to do is rearrange to get X on its own, but the question is, how do we get rid of the cos? Because what is the cos actually doing to the X? Is it adding, subtracting, multiplying, dividing, or is it doing something completely different? Well, remember what I said right at the start of the other section, that cos is like a function. So we're inputting X into the function cos. And if you think, with multiplying, if you want to do the inverse of that, you divide. With addition, if you want to do the inverse, you subtract, and vice versa. But with sine, cos and tan, you actually just want to do inverse sine or inverse cos or inverse tan. So the way that we write that is cos to the minus 1. And if I'm doing that to the left, I also need to do it to the right. So I'm inverse cosing the left. Need to do the same to the right, so I inverse cos the right hand side, so my 5 over 8.5. But remember, inverse cos is just the inverse of cos. So if these two are opposite things, it's like timesing by 5 and then dividing by 5. They just cancel each other out. So inverse cos and cos just cancel each other, and we're actually just left with X, which is what we want, isn't it? So all that I need to put into my calculator then is inverse cos of 5 over 8.5. And to get that inverse cos to come up on your calculator, you just need to press shift and then cos. So if I do that, so if I do inverse cos of 5 over 8.5, I've just got that X is equal to 3 significant figures, or actually we'll do 2 decimal places this time, it'll be 53.97. So in other words, I found out that missing angle there, X, is 53.97 degrees to 2 decimal places. Okay, the next example works in a very similar way. So yes, we're given 2 sides of our right angle triangle, but I'm trying to find a missing angle this time. So label the sides. Opposite here is going to be opposite. And this one is A. So we're not trying to find A and we're not given it, so I'm going to cross that out. So it's to do with O and H, so that's the SO part of SohCahToa. So in other words, sine of the angle X is equal to the opposite, which is 7, over the hypotenuse, which is 13. And now I just need to get X on its own, so I need to get rid of sine. Well, just like with cos, the inverse of cos was inverse cos, the inverse of sine is just inverse sine. So I inverse sine both sides here. So inverse sine of sine X do the same to the right, so inverse sine of 7 over 13. These two things are the inverse of each other, so they cancel each other out. So I'm just left with X is equal to inverse sine of 7 over 13. We put that in our calculators. Doesn't say what to round it to in the question, so the more digits the better. Make sure you do at least 3 significant figures though. So I'm going to do 32.6. So we found our missing angle x here, it's 32.6 degrees.